let's have a little bit of fun with the groove object and make a really basic looper. As usual, I'm going to use Anton.wave, and that is going to have to record into a buffer. It's been a while, so let's talk about that. I'm going to create a buffer object. I'm going to give it a name. In this case, we'll call it loopy. And I'm going to tell it how long I want it to store. So let's give it 250 milliseconds, which is definitely not all of Anton.wave. I'm going to then have that display in a waveform object, which I have to initialize with a message set loopy, which will set it to display what's in the buffer. And just to be on the safe side, I'm going to create a load bang to, if I can type, load that at start. So set loopy, and that will display what's in loopy. Not a whole lot here yet. Let's blow her up. Okay. To record, I need to create a record object. I need to tell it what I'm recording into, what the buffer name is. So loopy. The number of channels, I'm just going to do mono, so I'll do 1. And now I'm going to give it some interesting attributes. I'm going to give it the @ attribute. I am going to give it loop, which will turn on looped recording. Then I'm going to give it loop start 0. So it's going to start the loop at the very beginning, and loop end 250. So it's going to record the entire thing from the very, very first sample to the very, very, very last sample. I'm going to connect it up. Next, I will create a toggle to toggle the recording. If I turn the recording on and play Anton, you can see it. Cool. So I've just recorded part of Anton.wave. The entire thing is a little bit longer than 250 milliseconds, but we're only going to use that. Next, I am going to want to play this back. So to play it back, I'm going to create a groove object with new groove. Give it the argument of my buffer, loopy, and I could give it a number of outputs, but I could also just take the default, which is 2. It doesn't really matter. I'm going to send that to a gain, so I've got some sort of volume control. And then that will go to an easy DAC. Good stuff. Now, in order to communicate with Groove, I need to do a couple of things. First, I need to send it a message, which is going to be if I want to loop it or not. And since this is a looper, yes I do. I'm going to control that with a toggle. That just goes in there. And that will tell Groove that, yep, we're looping. Pretty cool. But when I start this, I also want it to start the loop. So I'm going to have a message start loop, which says play the loop from the start point whenever I turn loop on. I'm going to connect it to that toggle, and effectively it's just going to be like, hey, this is a bang, but okay, sure, I'll work with that. Next, I want to give it some initial values for where it's going to start and stop the loop. So I will create a load mess. I'm going to give it the values that I gave record. So loop start 0, loop end 250. Unpack. And these could be either ints or floats. It doesn't matter. I could even use zeros, which would just kind of give it the default int. And then I'm going to take element 1 and connect that to the middle point I'm going to take element 2, connect it to the right point. This middle point is where the loop minimum goes, and this right point is where the loop end goes. I can also take a look at those by just inserting a couple of number boxes so we can see what are those values we're getting. Cool. And you know what? Let's actually put these in sequence, because then I can use the number boxes to control where my loop points are going to start and stop. Hey, hey. Okay. In order to actually get sound out of Groove, I have to drive it with a SIG. So let's create a SIG. And let's also learn how to type today. And drop it there. Move these over a little bit. Going into SIG, I need to give it a value, some sort of float. But I want to interpolate between my values, so I'm going to use line 0, point, and 20 milliseconds. So it will always interpolate slowly, or well, very fast for us, but very slow for a computer. Put a float here so you can see the result. And that will connect directly into SIG. And finally, I'm going to start and stop this SIG automatic in terms of where I want it to go, to automatically start at 1, at playing at the full rate. So I'm going to create one last load mess with a value of 1. And this has the added bonus that I can also connect it here to the toggle, and that will automatically tell SIG to play everything at the normal speed, forward direction, and it will also tell loop to turn on and to start the loop playing forward. So here's my loop. That's pretty cool. Now, here's the fun part. This value that's going into SIG that I'm using, that controls not only the speed but the direction. If I give it negative values, it's actually going backwards. That's a lot of fun. Let's take that down to, how about negative 0.5, so we can hear it a little bit slower. Oh, that's fun. Now, if you look through here, you can see that this huge wave just kind of spikes and then dies down halfway through. If I wanted to go from the end to the beginning, so I'm going to start this at a maximum loop of 125. Let's try that. Okay, that's pretty smooth. I'm liking that. Now that I've got that set up, I could have a lot more fun here by creating a K slider, a live.dial, which I will set to mode float, and unit style is going to be MIDI note. And then if you remember from before, what I'm going to do is set that very, very, very similar to what was in our pitch shifter patch. So doing that, I'm going to use trans ratio, I'm going to use a float, I'm going to use some lines, and let's see what happens. So line line 0.20. We'll make this a float connect like so. Trigger bang float coming out of there to trigger the float. And then we're going to have another line of 0.20 milliseconds. These two are going to subtract the default value of 60 because that will be middle C. So we'll just set that right there. And then that will go into trans ratio because this is giving us speed values. So let's grab that speed value. Let's take a look at it and then let's send it out to here. So there we go. 1, 2 for an octave above, 1/2 for an octave below, 0.25 lower than that. All right, let's see if this works by turning it on. Oh, that's fun. So we've created a basic looper, but then we've also taken a look at what we can do that will help to create a sampler. And in fact, we're going to look at a different way to do that in the next video.